Hi everybody! Hi everybody! In this video, we are going to talk about evaluating functions, and at the end of the video, I want us to be able to evaluate functions at a given input to find the output and interpret the function in function notation. Okay, let's talk about function notation first. So, we as math people, yes, I said we, use a lot of different formulas and functions. So we have like y is equal to this and y is equal to that, and a lot of times it gets kind of confusing what we're supposed to use. So we like to give each function a name to make it easier to determine which function we're using when. So function notation is a way in which a function can be represented using symbols and signs. So this guy, f of x is equal to 2x minus 3. The f is going to be the name of that function. You can use any letter you want. Lots of times we like to use f for function, but if you want to get fancy, use the first letter of your name, use your favorite letter. It does not matter. Okay, next is going to be the x or the variable, and that is going to represent the input of the function. So notice x is the input. And then this last piece, the 2x minus 3, this is our expression, and it is going to represent our function rule. It tells us, hey, what are we doing to the input in order to get the output? Now, what's really important here is that this f of x, while it looks really fancy, it is just another way of saying y. So instead of saying y is equal to 2x minus 3, again, we get more specific and give it a name. But what I don't want us to think about is f of x does not mean f times x. It is just function notation, a way to be more specific and name our function. So in your brain right now, I want you to put f of x is the same thing as y. F of x is the same thing as y. Okay, so now that we know how to name them, let's talk about how to actually evaluate these functions. So when you are asked to evaluate a function, you are going to replace or substitute its variable with a given number or expression. So if we have the function f of x is equal to 2x plus 4, x is equal to 5, all it's saying is, hey, anywhere you see x in this function, let's replace it with 5 and see what we get as an output. So here's our function again. I'm replacing every x with 5, and then I'm just solving. So remember, f of 5 is just the way we name that function, so that stays by itself. We're going to use order of operations. 5 times 2 is 10, plus 4 more will give us 14. And a lot of times we like to write these as ordered pairs because sometimes they're going to ask you to graph. So think about what this means. The input that we input was 5, and the output that we got was 14. So we can write it as a point. Our x value is our input. Our y value is our output. So that means when I put 5 into the function, I get out 14. So this is one way they could ask you. There are a couple different ways they can also ask you the same question, but just a little bit different verbiage. So the first way is in function notation form. So they could say evaluate r of 6 given the function r of x is equal to 5x plus 6. It literally did the first step for you. It's like, hey, take 6 and put it wherever you see x. So you just need to also plug it in for the x in the equation. And then you're just going to use order of operations and solve, and we would get 36. Again, you could also write it as a point if you needed to. And lastly, you could have a multivariable equation. So sometimes they'll give you a expression with x's and y's, maybe z's, and they'll give you x is equal to, y is equal to. Y'all, all you're doing is finding the variable, plugging in what number it says, and then just using order of operations to solve. So we plugged in 2 for x, we plugged in y for 4, and then we're just solving this guy, and we would get 45. So it's really not super hard. It's just making sure that you're plugging in the right number for the right variable. All right, there is your overview of evaluating functions. If y'all have questions, come find me. If not, I will see y'all in the next one.